Alright, sorry about the video cut off on me. So this is part 2. We're going to start with some practice problems. I'm going to do the first practice problem for simplifying, and then the next two I'm not going to do on the video for time's sake. You should check the solutions after you have practiced them, and they are on Schoology. So this problem, what we want to do is we want to try to substitute in identities that we learned in the previous section of video notes, and substitute for anything we can, keeping in mind it's always best to say in sine and cosine initially. So if you look at this problem, the cosine is going to stay the cosine, plus the tangent we know is equal to the sine over the cosine. Make sure you write your w's. Don't get lazy and just leave off the w because it's a sine of an angle. W is acting like an angle. We always want to use proper notation. So all we did was substitute for the tangent. Now looking at this, we can simplify and do some algebra. So sine times sine is sine squared w over cosine. Now you may be thinking, why could he do that? Well, sine w can be written as sine w over 1. So we're just multiplying the numerators and denominators of the fractions. Now when we look at this, the next step to do is to make a common denominator. So we're going to come over here and multiply this by cosine w over cosine w. We'll go to the right. So then cosine w times cosine w would be cosine squared w over cosine w plus sine squared w over cosine w. Now that we have like denominators, we can add the numerators. When we add the numerators, we can go write that down if we want, but we know that the cosine squared w plus the sine squared w is equivalent to 1. So we're going to go ahead and write 1, and then we're just going to carry our denominator along. And we know from our reciprocal identities that 1 over the cosine is equal to the secant. And we are now done. Let's move on to the next page. Remember, try the next two examples and check them on the notes. Proving trig identities. Proving trig identities is very similar to simplifying, but what you'll notice is that you have an equal sign. When you prove an identity, all of these are different. They're called identities. They basically are really hard formulas. You want to pick the most complicated side, and you have to make it look exactly like the other side. That's how you prove an identity. You are not allowed to move things from one side to the other. That's why I've drawn the dotted line through the equal sign. You cannot move things on the left side over to the right, and vice versa. For these problems, I'd like you to try them and check them on the notes as well, but we will do number 2 together, because number 2 is a little bit more difficult, but I want you to try 1, 3, and 4, and then check them on the solutions on Schoology. So look at number 2. Some of the tips are, start with the more complicated side. I think the left side looks more complicated than the right side, so that's where we're going to start. When I look at the left side, there's really nothing to substitute. The cosine and the sine are pretty much simplified, so I'm going to go ahead and try something else. When I see a fraction and I see an operation in the bottom or the numerator, depending on where it's at, denominator or numerator, I might try multiplying by the conjugate just to see if that helps me. So remember, the conjugate is the opposite operation. When I do that, on the top, I could multiply it out, but I'm going to hold off just a second of multiplying it just to see what happens. I can always multiply it later. On the bottom, when I multiply, remember, you're going to distribute. So you're going to take 1 times 1, which is 1. You're going to take 1 times sine x, which is sine x. You're going to take negative sine times 1. However, when you take negative sine x times 1, it's going to cancel with the 1 times sine because they're opposites. One's positive, one's negative. So we really don't need to write it down. And then I'm going to take negative sine and multiply it by positive sine, which is negative sine squared x. Now once you see a sine squared or cosine squared or tangent squared, you should immediately go to the Pythagorean identities and see if that operation that's going on there, 1 minus sine squared, is an alternate form. And in this case it is. So we write down the numerator, and in the denominator we can substitute in the cosine squared x. Now that move really helped us because the numerator has a cosine function, the denominator has a cosine squared function. So think about in algebra, if you had x over x squared, you could cancel out an x. So that's what we're going to do. We're going to cancel out the cosine on the top with one of the cosines on the bottom. That leaves us with 1 plus sine of x over the cosine of x. Now from there, keep looking at what you're trying to prove. We're trying to prove the right side, which is secant x plus tangent x. That's what we must simplify to. Well, if you notice, the secant is 1 over cosine. If you look at the tangent, we know the tangent could be sine over cosine. That's pretty much what we have on the left side. All we have to do is split these up using our operations of fractions to pretend that we had a common denominator right before. So we split it up. 1 over the cosine is the secant, and the sine over the cosine is the tangent. Now the one thing that's going to be hard for you guys on this problem is no two problems are the same. This one I use the conjugate. On number 1, number 3, and number 4, I may never use the conjugate. You just have to keep substituting and trying some algebra. Refer the 5 steps above to help you, and the only way you get better at these is practice, so good luck to all of you. Remember, when you're done, check your answers with the solution guide. When you're done with all of those, then you can start your homework. I've loaded the books page onto Schoology, so that's right below that link, the link of the video notes as well. Good luck.